Let's make that stop. All right, Karen, stop it. You guys heard that too, right? So if you just now joined us, somebody's connecting. I don't know if they're going to get there. All right. Anyway, so we have some stuff about 1.7 to finish discussing. But before I do that, are there any specific questions from homework stuff or anything else? Okay. So let's do this. I'm going to pull my board over here. Forward. Come here.
Jeff, I did have something about homework.
Okay.
It had not the problems, but remember you told me how to go in, and it's only showing me like half of the page. So maybe I can get with you a little later and see how to see your responses to.
Yeah, I'm not sure what else to tell you if you're doing what I told you to do and it's only showing you part of the page.
Yeah.
I might be able to download it and email it to you if it just doesn't work. I'm not going to want to do that for everything though, but
yeah. Okay.
All right, so towards the end of class, we'll see.
Okay. Maybe it'll do different on this laptop. So it was on the
phone. The laptop should be better, I think. The phone definitely is missing some functionality.
Okay, thank you.
Yep.
Got it.
All right, let me see. I think that looks all right. Okay. Come here. All right, so a couple things. This is going to seem a little bit strange, but it's going to become very clear very soon. If you saw this, sure. Like maybe this is somebody did a problem and this is what they got. Is there a problem with this?
Yes.
What's the problem?
The decimal's in the wrong spot.
Yeah. So how do we fix it?
You move it between the 4 and the 7.
True, but then what else has to change?
Another exponent.
So there's 2 ways to do this. One way is to go, okay, I have to move this over once. He wants to move it 9 places that way. So if I move the decimal back once, now what does that have to become?
A 10.
Yes, because he wants to move the decimal that way 9 places. And what do? I come in there and I go, and then he's like, ah, shit, now I got to move it 10 places. How are we doing out there? This is going to happen in several different places, in several different ways, where the problem you're working with is not really in scientific notation. So we have to know how to adjust it. All right. Is everybody cool with that? If everybody is cool with that, I'm not going to show you the second way to do it. It's okay if you're not cool with it. Just let me know, because I have another way to do it.
Yes. Show us the other way.
Okay, I will. So that's one way. The other way is to say, and this other way works all the damn time, really straightforward. So focus on this piece. Write this guy over here. Get him out of the way. Go over there. How do I change this to scientific notation? I have to move the decimal once. And then it's going to be times 10 to the what? If I move the decimal once there, what's the power going to be?
10.
2.
First.
2.
Yeah. No. How many times did I move the decimal?
10. 1.
How many times did I move the decimal? Once.
1.
And why is it going to be positive? Because this was a bigger number, right? All right, maybe we need to take a step back.
Mm-hmm.
Let's take a step back. Let's review some scientific notation stuff, because if we don't have that down, nothing else is going to make sense. All right, but do you see how this ends up with the same? How do you do this?
You add them.
10.
Same answer, right? Okay, so let's back up. Because like I said, if you don't understand scientific notation, you are not going to get this shit, right? So it's got to build. So let's take a step back. I'm going to erase all this stuff. Change that to scientific notation. Don't say anything. Just do it. And if you missed yesterday's lecture, they're all up on YouTube, right? So let's do a little quick review of yesterday so we're all on the same page. So when I'm changing to scientific notation, what is my life ruled by? What do I find to work with? What do I have to find to work with to get scientific notation? What is it? I'm not sure if that's a weird question. I have to find a decimal point, right? Are you guys, what's happening today? You guys doing okay today? You guys out
Yeah,
there?
are you saying we need to find where it goes? Because we're looking at it right
No.
now.
First thing I got to do is find the decimal place.
Oh, okay.
Right? I mean, I'm breaking it all the damn way down, right? So if I find it, where do I need to make it go?
Behind the 3.
Good. I got to make it go behind a single digit. 1, 2, 3. So this is 3.98472 times 10 to the
Third.
1,
Third.
2.
Why is the 3 right? Because we moved it 3 times. So the exponent is related to the number of movements of the decimal place, which if you think about it, makes complete sense. Every time I multiply by 10, I move the decimal over once. So if I just count how many decimal movements there are, that's the power on the 10. That's how many 10s were involved to move it that many places. So that is the direct connection between just counting movements and the power on the 10. At first blush, you're like, why the shit would they have anything to do with each other? But then you realize, okay, it makes complete sense. So it's positive because, of course, this number is bigger than 10. Right? So how would I do? How would I do? And just, by the way, just so you know, normally we would take this and make it 4 times 10 to the third for most applications, because that's the most important part of the whole thing is the times 10 to the third. I like
So
it.
you rounded? Is that why you got 4?
Yes, very
Okay.
often, not always. Not in your homework all the time, but in real life, when we are discussing things in scientific notation, in science, the most important part of the number is this part. Right?
Is it always going to be 10?
Yeah, because our number system is based on 10.
Okay.
So to be honest, we could make the base anything, but then it would always be disgusting as shit. But because dividing and multiplying by 10 is easy, that just makes this a beautiful way to go. Can somebody tell me what's the English word we use for 10 to the third?
Cube.
What is this number? Somebody read this number for me.
3984.72.
No.
3,984.70.
3,000. Oh, so 10 to the third is 1,000. So somebody read this number for me in English.
1,000.
4,000. Isn't that roughly what this is? 4,000?
Yeah.
Okay, so, okay. I also want to discuss that. I want to kind of start it in your brain a little bit, that certain 10 to the certain powers relate directly to our English words like 1,000, million, billion, trillion, and beyond. Okay. Like, have you guys ever heard of gigaton? If you've done any history about dropping bombs on certain places, then you've heard of a gigaton bomb. Right? Or how about anybody into computers? Has anybody ever heard of a megabyte? Kilobyte. Kilo, we're used to. We know what kilo means, especially if you watch a lot of cop shows with a lot of cocaine floating around. Kilo, what does kilo mean? 1,000.
Kilogram.
1,000.
1,000. I like it. So kilogram is 1,000 grams. Kilometer is 1,000 meters, so forth, right? But then we have stuff beyond that. We have gigaton, megabyte, kilobyte. Has anybody heard of a terabyte?
Yes.
Anybody? There's terabyte drives. Tera is way above giga. It's crazy. So we're going to talk about that in a minute. Just to get that in your brains. All right. So what about this one? So find the decimal. Where do I want to move the decimal to?
Between the 2 and the 9.
Yeah, so there's a single digit in front of it. So 1, 2, 3, 4, 5. So what's it going to be? 2.9 times 10 to the,
5th.
no?
6.
Yes.
1, 2.
Excuse me, Jeff.
Yes.
Back to the question number 1.
Sure.
To the sample 1. I know. So did you round 4,000 times 10 to the third power? Did you make that a 4 just because the 9's bigger than the 5?
Yes,
Did you round?
exactly.
So
If I was going to round this, I would round it to 4. Yeah.
okay.
And again, 3984 is roughly 4,000. If I rounded this number, isn't it roughly 4,000?
Yeah. Yes. Yes.
Am I saying you're always going to do this? No. I think I
Yes.
made a
No.
huge deal out of you're not always. But most of the time, if you're dealing with big or small numbers, you're going to round this piece because this is the most important part. So if somebody said, I'm going to give you 7 money, right? So like you, what the shit? Not $7, just 7. What are you going to say? 100, 1,000, million?
Yeah.
So what's the most important number there is, or what's the most important part is it 1,000? Is it million? It's going to cost you about 50. Have you seen this stupid scene in movies? And the guy goes, 50,000? No, million. It's like, so that's the most important part is that if it's 50,000 versus 60,000, that's not as important as 50,000 versus 50 million.
Yeah.
Is that, do you guys with me?
Yeah. A
So
little bit.
you always round? No, but very often we do because that is the most important part of the word. That tells me if it's 1,000 or million or billion or trillion or even beyond, right?
So the third power lets you know that we're rounding to the thousands.
The third power is because it came from 1, 2, 3 decimal movements.
Okay, so we have
Yes.
to. All right.
I want to be more careful with that because in a sense you're right, but I don't have a word for every, what's 4 decimal places? There's not a word for it. That would just be the 10,000s. So it's the power is directly related to the number of decimal movements. And some of them have English names.
Yeah.
Okay.
And
All right.
okay.
Okay. So
We
what
can move
about
on.
this? I agree that the number is 5. Is it positive 5 or is it negative 5?
Negative.
There it is. So I love it when I said it wasn't 5 and everybody went to 1 and 6. I'm like, wait, no, we know it's 5 because I moved the damn thing 5 times. But it's negative. Why?
Because you move the decimal point to the right.
Yeah, remember, I suck at left and right. So it's a small number. It's so much easier. So even if you're good at left and right, it's just easier. It's small, got to be negative. It's big, it's going to be positive. I mean, I think that's perfectly fine. Why am I okay with a less technical sounding thing? Because what does a negative power, stay with me. What does a negative power mean? Who remembers? What's a negative power mean?
Divide.
Yes, it means flip it, right? So am I really multiplying by 5 tens? No, I'm dividing. So what happens every time I divide by 10? It gets smaller and smaller and smaller. So why is it negative? Because it's a small number. Those go directly together. Because the negative power means I'm dividing, so it's making it small. The left and right's kind of dumb in that sense, unless you remember it that way, which is fine. Whichever way you remember it. Okay. All right. The few faces I see have kind of a medium tone to them. Not happy, not sad, not confused, not just sort of in the middle somewhere. Okay. All right. All right. So now let's step it up. Let's do another example of what I was doing earlier. So what if I had this? Let me make it a little more interesting. What's wrong with that?
The decimal point's in the wrong spot.
Yeah, where should it be?
After the 9.
Yes, so let me do this two ways. Here, the first way is the way that I do it, which is funny because it's not as mathematical. But I'm probably the least mathematical math teacher there is, but that's all right. Because I like to think of it in broader terms. So this is the way I do it. What does this power want to do with the decimal? Wants to move it which way? Wants to make
Move it
this
back one.
No. Does it want to move it forward or back? This power.
Forward, I mean, yeah.
Yeah, it wants to make it bigger, right?
Right.
How many times? It wants to move it that way 13 times. No, it wants to move it 13 times.
Right.
We have to move it once. So if I move this decimal once, have we done some of this guy's work?
Yes.
So now he doesn't have to move it 13. He only has to move it.
Well, that's
Well,
Yeah. I'm with you. I just want to make sure everybody else gets there.
okay.
All right. Now, what's another way to do this? If you don't like that way, there's a more mathematical way to do this. If I ignore this for a minute, I'm just going to write this over here. And I focus on this. How do I write this in scientific notation? It would be once back, so 9.27 times 10 to the what?
-1.
-1. And then what do I do with those?
Give them like
You
like basis. You just go ahead and subtract that one.
Yeah, add these, which means subtract the 1. I like it, right? You add them, but one's negative. So either way you look at it, you get 12, right? Same answer we got there. So if you ever have a piece times 10, and this piece is not in scientific notation, you can make that piece in scientific notation and then just put those 10s together. Or if you understand the way I look at it, it's a little bit quicker, but it's a little bit vague also. You don't have something you can latch onto. So either way you can do it, it's good.
And I have a question. So that's the answer. You don't have to simplify that.
No, there's the point of this problem was to write it in scientific notation. So this either somebody didn't do it right and you're correcting it. Like if somebody gave me this answer, I would say, what's wrong? The decimal's in the wrong place. You have to correct it. So these are two ways you can get to the same answer, two different ways you can correct it. We're going to see also in a minute a different place this could come from, but just, all right, I want to make sure you guys get this idea. How do I adjust something that's supposed to be in scientific notation that isn't? Do you guys feel a little better about that? No, I can't read you guys.
Yeah, I feel a little better.
You feel a little bit better. All right.
Yeah.
Like, yeah, I felt like shit before. Now I feel a little less like shit. Okay. So, all right, let's do one more. Let's do one more. So what if I had, what you got, Jeff? So again, let's do it two ways. I'm getting the feeling that you guys don't like my way as much. So let me do the other way first this time. So I'm gonna write times 10 to the -12. I'm just gonna write that piece there. Let me focus on this dude. How do I change him into scientific notation?
Jeff,
Yes.
I guess my question in the other, back to the sample that we just finished, 0.927 times 10 to the 13th power. Why do you move the decimal? Is it 13th power or how do you? Is that the proper?
So I want to make sure. This is a good question. I appreciate this. I am not, if I wanted to change this, okay, a different question, I think this is your question, would be how do I change this into just a decimal number? How many times would I have to move the decimal place? You're muted, Sal. I don't know if you're talking to me.
I'm not sure, Jeff. I'm asking you.
Well, no, okay. This is something everybody should know. If I wanted to change this number into just not scientific notation, how many times would I move the decimal place? What does it say to do?
Negative 12.
And what's the negative mean? Don't say negative. What does that mean? Move the decimal place
Left.
back, make it smaller, right?
And how do you know? My question is, how do you know when you go right or you go left? Depending
Negative.
where negative.
Negative.
So
Power tells you if I want to make this small or big. So like I just said, why does that make sense? A negative power means flip it. So I'm actually dividing by 10, which is going to make this 12 times smaller. So when it's a negative power, you move the decimal back.
right, and it doesn't matter.
Say again?
And it doesn't matter if you have a small number right on the left side. It doesn't matter how big or small the number is. You're gonna always just follow what the power
If I'm
is.
taking something that's written in scientific notation, the only thing that matters is what the power is. I don't give the first shit what this is in that case. Now, does everybody understand that the problem I'm actually doing is not the problem I just said? I am not making this. So what would this be? I'd have to move it back 1, 2, 3, 4, and then 8 more places.
8 more
right?
spaces, yeah.
5, 6, 7, 8, 1, 5, 7, 9, 2. All right, that's just converting this into what the book calls a decimal number, which just means not scientific notation. You guys with me? That's what that power tells you to do. Move the decimal back 12. That's not what I'm doing right now.
Okay,
What I'm doing, is that cool by itself?
that's cool by itself.
All right,
what's
so what
next?
I'm doing is somebody did a problem. Their answer was supposed to be scientific notation, and they do this. That is obviously wrong. Why is that obviously wrong?
I don't know,
Because the
Jeff.
number is bigger than 10. I mean,
Yeah.
it's too
Bigger
big.
than 9, yeah. So I
9
know that decimal should have been there.
behind the 1.
Yes. Okay. So we're trying to correct that mistake. We're trying to take this number that's sort of a mixture of scientific notation and make it purely scientific notation. That's all we're doing.
Jeff, I wish I could remember this stuff.
Oh, what the hell's happening outside? Sorry.
I can hear it too.
Somebody's announcing something in Spanish, and I'm like, that's not going to help. But hopefully it's not. I was going to see if I can get somebody to translate if anybody spoke Spanish, but they're gone. They've moved on. Sorry.
So we will be 1.5.
Yeah. Okay.
9, 2.
Does everybody understand that we are not doing this problem right now? That's just move the decimal back 12. I don't care where it is. Wherever it is, you move it back 12. In that case, that problem's easy, but that's not what we're doing. So if I write this piece here, how do I change this piece into scientific notation? I've got to move the decimal.
1, 2, 3.
Yeah. And that would be times 10 to the what then? What we just did.
-3.
No.
Minus
I
9.
mean, ne-
3.
This is why I hate stay with me, guys. Stay with me. This is why I personally, not just because I had trouble with left and right when I was younger, and I still do,
right.
because of the fact that if I'm changing it this way, I move the decimal one direction. If I do it the other way, I do it. It's just dumb to me. If I just remember big, positive power, big. I don't have to worry about left this time and then right that time. It just always got me. I was like, what the shit? It's just so much easier to think positive means big. So if I have a bigger number, I'm going to have a positive exponent. So I had to move it 1, 2, 3 places. It's going to be +3. And then, of course, I end up with what overall?
Times 10.
9.
-9. So all we really did was pretend like that's not there. We changed that to scientific notation, and then we added that in, that extra piece that's out there. So what's the other way to look at it? In case there's anybody out there that doesn't like this way, let me show you. The other way is less mathematical, like I said. This wants to move it 12 places back. I want to move it 3 places that same direction. So am I not doing some of his work? See, this way I love to look at it, but I always know that not many students like this way. But again, you got 2 ways. You can do it either way you want to. I love this way because now I can just go 1.5792. I moved it 3 back for him. He's only got to go back 9 now, which is the same damn answer we got there. It doesn't matter. So this way is more math, but you don't have to kind of like reason, okay, I'm going this way.
Okay.
And this way is less math, quicker, but you have to kind of reason. He wants to go that way. I'm going this way. So it's really up to you which way you want to do it.
So Jeff, necessarily, you don't have to move the decimal 12 times, even if it's a negative number. You don't have to move the decimal 12 times to the left. You can just move it as many times within the number frame.
All right. It depends on the question. If the question would have been, rewrite this in decimal form, this is what I would have done. I would have moved it back 12 because that's what.
But that's wrong. That's wrong or that's right?
Decimal form.
If the question,
That's wrong.
if the question had been, convert this to decimal notation, that would have been right.
Okay, decimal notation.
The
And
question we're doing, it's wrong because that's not the question. It was put this into correct scientific notation.
decimal notation and scientific notation are 2 different types of answers.
2 opposite things, yes.
2 opposite things, okay.
One has times 10 to the part to it, and the other one doesn't. It's a normal everyday number. Yeah, I like it. Good, good, good.
Thank you. I understand that now.
I like it. And to be honest, I think, let me get, everybody got what they want from this?
Wait, hold on.
Sure. I'm going to take this top part away. You got the top part. So let me ask you this. Let me make sure we can all do this. I think we did one like this. I'm pretty sure we did. Like, can you guys rewrite that in decimal notation?
You can erase that. You can erase the bottom part and we'll just start again.
Yes, so do this. Rewrite this in what they call decimal notation. And then I want to ask, so fundamentally, what do you have to do? What part of this tells me what I have to do?
It's positive, so you move it to the right.
This part tells me what I
The
have
decimal.
to do. Yes, so I want to move the decimal, I want to make it bigger. Positive number, right? So does somebody have a shortcut as to how to do that? Because I'm going to have to add some zeros. How many zeros do I have to add?
4.
4. Why? Because you got to go once, twice, and then I got 4 more places I still have to go. Now, what number is this? How do you say that?
280,000.
Say it again.
1,280,000.
So 10 to the 6th in English is million, right? So if I said I just won 5 times 10 to the $6, that's another way to say I won $5 million. I like it. I like it.
Okay, I have a question or a
Yes.
note on that. So you made it into 1 million, and because you moved the decimal point, so it does have to do with millionths place and tenths place and all that, and the hundredths place, or is it just?
Yeah, it does. Because how many places are after the 1 here? 1, 2, 3, 4, 5, 6. That's why.
Yeah,
10
because
to
I saw that
6.
it was 6, but you only moved it 2 times, so that's where I was like,
Oh, no.
what?
I'm sorry. Okay. The long ass way to do this is just to add a bunch of zeros. I gotta go 6 places, right? And then I go 1, 2, 3, 4, 5, 6. And then I can forget about those, right? That's kind of like the way you can do it, but that's silly. What's the
Yeah.
shortcut? I've got to go twice just to get around the numbers. So I have to still go 4 more places past that. So then I can just add 4 more zeros, right?
Yeah.
I like it.
Okay, I got it.
I like it. Okay. Because one mistake I see is somebody thinks you just add 6 zeros on the end of this. Well, no, you don't. You add 4 zeros on the end because you had to go twice just to get around the 2 and the 8. Do you guys see that? So don't make that mistake. Don't just add 6 zeros on the end. That doesn't make sense. So what about this one? Get in there. Somebody's calling me. What the shit? I gotta put this phone on. What do you call it? Who is that? Oh, unknown name. That's always exciting. All right.
Okay, Jeff, you have a negative, right? And you have
Wait.
4. Well, how do
Yeah.
you pronounce that number, the negative number? What's the proper math word? It's just
No.
negative 8
This is 4.09 times 10 to the negative 8.
to the negative 8. Okay.
Yep.
So 4.9, since we're dealing with the negative 8, you're gonna move it 8 times, but you can only move it 1 time to the left, and then the 7 remaining numbers, negative numbers, you move it to the right.
No.
Oh,
You
fuck.
almost had it. I was like,
Excuse
please,
me.
I got to move it once, and I still have to move it 7 places. Which way? That way. That's what negative means. So what are they all going to be? The other 7 things are all going to be
They're gonna be zeros.
zeros. Done. I love it. So the shortcut for negative powers are always easy. Always.
But are you gonna do that math? That's math solving, like the way you're doing the math. How do you say it? The way that you're doing the math problem, is that for decimal notation and scientific notations?
So it's currently in scientific, and the problem would say
Uh,
change this into decimal notation.
okay, I sound like an idiot.
So
I know.
what's
All
weird
right.
is we would normally not call this decimal notation, but it is because the decimal's in the right place. That's all that really means. So
But
decimal,
the type of problems that we're doing, they're called scientific notations.
it is working with scientific notation, exactly.
And we're just making them into decimal notations.
Because we have to be able to go both ways.
Okay. But we already know there's only 2 ways. The scientific notation, which is the question.
Exactly. So that makes sense that there's 2 ways. I could either give you this and you change it to this, or I can give you this and you change it to that.
That's gonna be on the exam. Like we're gonna get questions on the quiz. Okay.
Yeah.
All right.
Okay. So,
Thank you.
Question, Jeff.
yes.
So just as we count towards the whole number, I like to call it, which is the right, we use on the negative side when we're negative 8, that first slot is number 1.
Yes. And that's why the shortcut for negative powers is exactly what Linnell just said. I'm always going to have how many zeros in front of the whole number, which is fine to say, Linnell. I appreciate that's a perfect way to say it. The whole 4. How many zeros will I have in it? 1 less than this.
Right. That's exactly what I meant.
Movements. He gets 8 movements. We took 1 just to get around that stupid number.
Right.
So then, of course, I'm going to have 1, 2, 3, 4, 5, 6, 7. zeros.
Yeah.
1, 8. maybe.
So that, Mr. Jeff, that's the answer then.
Mhm.
Yes, that would be the answer because the question here was convert this into decimal notation. That's all that problem wanted you to do.
Oh, I skipped.
Some of
Okay.
the homework would be that, and some of the homework's going to go further. It just depends on what the question is.
Hey Jeff, but you know how you're going back to, hey, if somebody wants to request like $1 million, they'll be like 5 to the 6,
10 to the 6, yeah.
10 to the 6. Oh yeah, 10 to the 6 because that's 6 zeros, and that's so
Good.
that would be okay.
That would be $1 million, yeah.
That'll be $1 million. So if in broader terms, I will be like, hey, you know, I'm trying to get a loan 10 to the 6. Like,
Yeah.
would you go to
So-
the bank and talk like that? Like people
No.
talk like that?
So in finances, so I really want you guys, what we just figured out is English does what math does in a different way. Math uses 10 to the 6th, and English uses the word million.
Okay.
So in English, could I write 5 million like this, right? In a paper, I could write 5 million like that, or I could write it like this. Right?
Yeah.
Right?
Yeah.
They both mean 5 million, and mathematically, this also means 5 million. It's just that this and this accomplishes the same thing. They both take the place of all those zeros. And of course,
Thank you.
trillion makes even more sense because that's a bunch of freaking zeros.
Well,
I
yeah.
could just replace it with a little word.
Okay. Now,
right.
Jeff, the number that you broke down, 4.9 to the
4.09. Yeah.
10. How much is that? That's nothing. That's just chump change,
Oh.
right?
We're going to get into that.
Okay.
Yeah, it depends. If you're talking about the distance between atoms, I mean, this could be huge.
So that
So
number, this math,
chemistry, physics, stuff that deals with really small distances, you're going to have these. And of course, you guys all have heard of a millimeter, right? What does anybody think a milli means? Or even better, let's go centimeter. Centimeter. You've all heard of centimeters, even though we live in America, which in terms of units, is the most backwards country on the face of the earth. But oh well, we're doing what we can. What does centimeter mean? Does anyone know what centimeter means?
100th of a meter.
Yeah, exactly. It's 1/100th. Why does it make sense? Because centa is from Roman, centum meaning 100. So like 100 cents in a dollar, right? 100 cents. Did you ever wonder where the hell did cent come from? Well, that's where it came. Centimeter is 1/100th of a meter. It takes 100 centimeters to make a full meter, just like it takes 100 cents to make a full dollar. You guys with me?
can we go back to the questions, to the decimal notations?
I
Oh,
will.
I'm sorry. I don't mean to be rude, Jeff. You're, my bad. My
Do what
bad.
I want to do, but you can always ask a question about what I'm doing.
Okay.
All right.
Yeah. I'm really focused right now I'm focused on everything that you're saying, but right now you got my focus on that scientific notation and breaking it down. And
Sure.
my
All right,
bad.
here we go.
Apologies.
That's all right. I just like to address what's currently up. All right.
Yeah, you were answering my question though. You were answering my question because
What was it?
the
Sorry,
decimal
what was it?
notation that we did, you said it could be used for other, like for chemistry. It could be used for
Yes.
to describe a certain distance. I understand.
Yes.
So you were actually answering my question. Thank you.
Sure. All right. Now, let's take the next step up. And I want to show you where the first thing we were doing, where it comes into play naturally. So the first step I'll do is something very simple. Just make sure we're all on the same page. How do I do this? How do I multiply those together? Well, what am I able to multiply together? Can I do 2 times 4?
Yes.
Yes.
8.
Do 10 to the 5th times 10 to the negative 8.
-3.
Subtract.
Done, right? Are you guys with me? We did a problem just like that yesterday. So I just want to make sure we're back on that page. This is the next level of what I can do with stuff in scientific notation. Can you imagine what these numbers look like? 2 times 10 to the 5th is 2, 1, 2, 3, 4, 5 times 0.00000004. I mean, do you want to do this or do you want to do this? I mean, holy shit, I'd rather do this, right? Screw this. Jeez. Do you guys understand? Do you want to do this problem by hand?
No.
No, I'd rather do this. It makes it easier. That's 8. I can see how many 10s.
Shortcut, yeah.
Yes? You okay? Okay, everybody's okay. Now, here's where a problem comes in. Let me introduce a problem. This is all nice and good because why is this okay? Why is this okay? Why is it in scientific notation? Because that number is less than...
The ones place.
Yes, it's the one whole number, right? It's a single digit. Okay, so what if I had this? Now you start to see why I did what I did, the very first thing. I did what I did before love came to town. All right. So I do the exact same thing. The first step, no problem. The first step, same thing. What do I get?
30.
30.
10 to power 20.
No. It's a -7.
6.
6.
Everybody cool with that? Now, why is that wrong? Somebody's face went, what are you doing? That's right. I did it. You did it too, Jeff. But that's wrong. Why? Is that in scientific notation?
No, because 30 is too big of a number.
Yeah,
So take
that's
a minute.
over 10.
Don't say anything. We already discussed earlier 2 ways you can do this correction. Now you see where the correction might have to happen naturally. Correct it. Don't say anything out loud. Don't chat anything. Just do it. Whichever way you like better. Make this into scientific notation. Because it currently isn't.
But you said 10 to the 6 is a mil, so it's 30 mil.
Yeah. So that's fine, but that's not the question. This is not in scientific notation. I want
it's
it
not.
to. Yeah, so it's not because this is a number that's bigger than 10.
So we have to move the decimal point.
Yes. So this is the very first thing we were doing today. I showed you 2 ways to do this. So you could do it either way.
So we move the decimal
Well, don't
one.
say anything. Wait. Sorry, Sal. I just want people to work on it first.
Okay. I'll work on it.
Okay, so at this point, I think everybody should have tried something.
Is it wrong because there is another 10th in it, in the theory? Like,
30 is not a single digit, therefore it's not correct. This is not in scientific notation or decimal notation. So I want it in scientific notation. So the decimal should be where? It's supposed to be where?
3.
Behind it.
Behind the 3. So currently right there. So one way you can do this, like we did earlier, is you can focus on this guy. How do I write him in scientific notation? I got to move the decimal 1, so it's 3 times 10 to the
6.
First. First.
Oh, yeah.
And then you have this on the side, right? That's sitting over there. So I just rewrite this. I rewrote that times 10 to the 6th. So this becomes 3 times 10 to the
7.
7.
The other way to do this, the other way to do this is that wants to move it 6 places that way, right? I move it back once, so now it's got to move it 7 places that way. Same answer. Either way you want to do it, whichever way makes sense. If neither way makes sense, this is bad. You have to ask me questions. But if one of the ways makes sense, do it that way. You can forget about the other way. Doesn't matter. Okay, maybe. Now, so this is going to happen in the homework.
Can you do one more problem just like that, Jeff?
Sure. All right.
Thank you.
Let me make it more interesting.
I'm quite getting the lesson. I'm getting the,
Sure. Okay.
so thank you for that. But if you can just do the question one more time, I appreciate that.
And I will. All right. So let's see. Let's do. Sorry. Yeah, let's make it gross. Why not? Yeah, yummy. So if I was making you do all this by hand, you could do, what do you do first?
Multiplication of 4.3.
Find a decimal.
No. We're not changing anything. We're just doing this multiplication. 4.3 times 6. So you can do 4.3 times 6, 8, 1, 25.8. Is that all right? So you get 25.8. You can already tell there's going to be an issue, right? Times 10 to the what?
Negative 36.
Beautiful. Right? You add the powers when you multiply like bases. They're both negative, so they get even more negative. All right, let me stop there for a minute. I'm not done. So let me do it my way first this time, and then we'll do it the other way. So can I take away this other problem just so there's not so much on the board?
Yes.
All right. Okay. So one way to do this is to say he wants to move it back 36. If I move it back once, he only has to move it back
35.
5. Done. See how that's why I love that way. But it takes a little bit of reasoning, but it's quicker if you get it. If you don't get it, so what? Everybody's different. Some people get some stuff and some people get other stuff. Who gives a shit? So the other way to do it is to put him to the side, right? Don't worry about him for the moment and focus on him. How do I make 25.8 become scientific notation?
2.58.
10 to the
First.
Yes.
and then of course, what do you do with these?
Subtract.
Yeah, I like it. So you add them and that's negative, so subtract. 1 minus 36 is
35.
Negative 35.
Yes, you got it. So that is a natural place where that adjustment comes in. It wasn't our fault. It's just that this part became too big. Oh shit, we better adjust it. It's a natural thing that happens in these kind of problems.
So we just have to remember that when we convert it to scientific notation, the decimal has to be after the first.
Definitely.
Okay.
It can only be, there needs to be one number, 1 through 9, in front of the decimal place.
Okay.
I
Okay.
like it. I like it. Okay, all right, so last thing, let me see, what time is it? Oh, maybe not the last thing. I want to show you something. I tried to post this to Canvas. It got on there a little bit weird. I want to show this to you. You can do it, Jeff. Get in there. Where are you? There it is. Sweet. Look upon this. Sorry. I have to be creepy every now and again. Look upon this. What do you see? So, do you see what we're talking about? For example, right here, million. Million is 10 to the 6th, right? We talked about that earlier. Let me zoom. Oh, I guess that's as much as I can go in. Can you guys see that okay? If you're on a phone, probably not. But do you see how there's even a quicker way to say it? This is where mega comes from. Megabyte. Megabyte means 1,000,000 bytes in computer. Megaton means 1,000,000 tons of TNT. So if you drop a megaton bomb, that's how much TNT you're dropping, is the equivalent. You guys with me? And then you probably see some words that look familiar, and you see some words that don't. There's giga that I was talking about earlier. That means a billion. And has anybody ever seen the movie Back to the Future?
Yes.
If you haven't seen the movie Back to the Future, write that down and watch it. It's not official homework. I can't make it homework, but holy shit. Anyway, sorry. Do you remember how much energy they realized it needed to be able to go through time? The car.
1.21 gigawatts.
But how did they pronounce it? I always love this. Do you remember? They didn't say giga. They said giga, which is hilarious to me because I actually read this book about the behind the scenes, and they just said they never checked with anybody. They just decided that's how it was pronounced, and they got in the movie, and all the scientists around the world like, oh, come on, you could have asked any of us, come on. Anyway, so that's what they meant was gigawatts. You guys with me? No? If you've never seen the movie, you're definitely not with me. I'm sorry. And then you see the tera I was talking about earlier, like terabyte, teraflop. I don't know has anybody ever heard the word teraflop? That sounds like, man, you failed so hard. That was not just a flop, that was a teraflop. All right, no, that has nothing to do with it. It has to do with how many computations a computer can do. Then you see some other, there's centi. We all know centimeter, millimeter, but then there's micro. What's interesting is how do you pronounce the word micro when you put it with meter? You actually call it micrometer. Or you can call it micrometer, which sounds kind of weird to me. But then you got some other stuff. Nano. Anybody ever heard of nanometer?
Yeah.
And in fact, isn't that the name of, what do you call it? The suit, Tony Stark's Iron Man suit's made of nanobytes, nanotechnology. So that's on the order of a billionth big is what that means. They want to create little nano computers, little nano robots that they can put in your bloodstream and that would clear clots. They're hoping that someday they'll be able to do that. So we'll all be walking around with little robots flowing through our bloodstream. Sounds like the beginning of a horrible science fiction movie. And then there's pico or pico, and then there's femto. Anyway, so that's like really crazy. This is when you're talking about the distance between a proton and an electron and an atom and shit. I mean, this is where you get like crazy tiny amounts. Anyway, okay. So I posted that up on the website under Unit 1. You have to actually download it to look at it. But you don't have to memorize this. Please, dear God, nobody just start memorizing this. I just wanted to give this to you because every now and again, these kind of things pop up in movies and news stories. So I just want you to know what the hell they're talking about. Okay, maybe.
I feel like this is gonna help a lot, or you wouldn't want this to help, because I feel like this is perfect to like use for the homework if you don't know like your place value, which I don't.
Yes. So you could anytime they say 5 million, you know exactly what it is in scientific notation now. So I want to take this one step further. So this is where you could use this type of thing. So let me see. Let me try to write. All right. Let me see let me stop sharing first. Sorry. Hold on. To make technology work, I have to shift my, my screen that I'm working on. Here we go. So that my little pen dude will work. Come here, pen dude. All right. Let me pull him back up. Shapow. So if I had, let's see. I got to actually do this. Annotate. Let me make it so you guys can't annotate also. All right. And then I draw. So what if I had like 75? Oh my God, Jeff. All right. Good start. All right. What if I had 75 million? I can take this and make it 75 times 10 to the what? This is the one we're all going to know for sure. What's a million? 10 to the
6.
6. And of course, what's wrong with that? Now I can just adjust it a little bit. Do you guys see? So I got to move that back once. So it's going to be 10 to the
6. 5 now. 7 more because you moved it back one.
I love it. I'm not going to do the other way just because if you understand the other way, you can do it that way. So now watch this. This shows up in the homework somewhere.
Oh,
Hold on. What if I had, what do you got, Jeff? 1.56 times 10 to the 8th. Is 10 to the 8th anything special?
No.
All right, now what I'm about to do, you don't have to do it, but it makes it a little bit easier. Just stay with me. Stay with me. Come on, we can do this. What is the next thing down from 8 that has a special English name?
million.
6.
So if only that was a 6. So if I move this, let me see if you guys are with me on this. If I move this twice, make it 156. It's no longer scientific notation, but I don't give a shit. I'm trying to change it to English. That's my question right now. Won't this be times 10 to the 6th now? Because all right, I moved it over twice. And so that's 156, what?
Million.
Million. Yeah, bam, bam, bam. So if you get a 10 to the something that is not one of these, you just adjust it. So if I had 10 to the 11th, I would adjust it to be 10 to the 9th because then that's billions.
And you do that by just moving that decimal to that place.
So if I had, let's try one of these freaky ass ones down here. If I had, this could be a little bit more interesting. Let's find out. 7 times 10 to the negative 4th. Does that match up with anything?
No.
No,
No.
but you can take it to the, what's that?
What's
Thousand?
the next one down from that? So negative
Down.
6, the next one down,
Million.
right?
Million.
This
Do you
is where it
always
gets
have to
weird.
go up? To the
You
next
always
one?
have to go down. Do you see how I made 8 go down to 6? Do you see how I
Okay.
made 8 go down to 6? Yeah, so now watch. This is a little bit freakier. I don't know if this exactly happens to you in the homework, but it's exactly the same idea. So if I move this over twice, 1, 2, I make it 700 times 10 to the negative 6. I don't know if you guys get that. So then that'll be 700 micro whatevers. Because now it matches up with this. So do you see, watch this. When I move this over twice, what did the power do? It went down. So if I move this over twice, what will the power do? It will go down too. It's the same thing. Why did I do that? Because now it matches up with one of my prefixes. It matches up with micro, which is this neat little character.
I think it's this, I have to wrap my mind around it because the number in my head I see it going up, but it's really going down.
Since that piece is getting bigger, this
Yeah.
piece has to get smaller so they average out to be the same number still. That's exactly what happened over here. This piece got bigger, so this piece had to get smaller, so it's still the same number.
Right. And what I was saying is that because it's -4, when I see -6, my mind says that it's bigger.
Oh, well, your mind needs to stop doing that.
Yeah,
to you.
that's what I'm saying. When I see a 6 over a 4.
Real quick, I'm glad you brought that up. You're not the only one that has this issue. But on a number line, which direction is smaller? Left or right?
Left.
Yes. So when I plot -4 and -6, who is further left? Here's -4, here's -6. So -6 is smaller because it's further left.
Right.
There, that's it. Don't look at the 6, it's negative. So the situation that is worse is the one where I owe more money. So this is the worst situation. That's smaller. I have less money because I owe more. Okay.
I think it seems
I
confusing
totally get
with
it.
all these numbers and what you write in. Like we're looking at all these zeros and it's like, oh my gosh.
So let me give you a different way to do this. Let's look at the actual book. Let's look at an actual problem in the book. Just so you guys, I'm gonna take this away. All right, I'm gonna stop sharing. And that's up on the canvas shell is this whole thing. If you want to look at it now, shaboo. So let me show you something in the homework so you don't freak out overly much. Let me see. Where's a good one? Let me find one. Hold on. Oh, okay. Here's what I'm talking about right here. Okay, let me share this. Where's my, oh, I got to pull this over here. There we go. Up, up, up. So this is not in the actual homework. This is, oh geez, what page is this? This is on, oh crap, I can't move around. Here we go. Page 90.
Page 94.
Yeah. But you guys see, this is exactly what I'm talking about. And before this, they kind of show you what this means. I don't know if anyone's read through the book yet. Does anyone know what the hell that means?
No.
So what that means is, on a graphing calculator, it shows times 10 to the as the letter E. So this means times 10 to the positive 10. That's what that E plus 10 means. That's all it means. Right? So how in the world did they get 16 billion? Because they did what I said earlier. They took 1.6 times 10 to the 10.
Decimal once.
Moved the decimal once. And so that's 16 times 10 to the ninth. And 10 to the ninth is a billion. So let me show you. The book actually shows this to you also. Let me stop sharing and show you the part in the book that shows this to you. I'm going to stop sharing right now for a minute. I don't have to stop sharing. I just have to clear my chicken scratch. I'm going to clear that. So let me go up here, right here. That's kind of a more concentrated chart of what I showed you earlier. Are you guys with me? So that's why they made it, they should have showed some work here, but oh well. That's why they made it go to billion, because I can go down from 10 to 9, and that's billions. So if I have 11, I want to go down to 9 still, but I have to move the decimal how many times now? For this one, for this 1950 debt?
Twice.
11.
Twice. You guys see the next number that makes sense is 9 still. I'm at 11, so I got to make it move twice, and now it's going to be 257 times 10 to the 9th. Let me clear that. Let me show some more work. All right, let me put it up here. So if I have 2.57 times 10 to the 11th, is everybody cool with what that E plus means? It just means times 10 to the. So if I was teaching a class where we were using the graphing calculator, the TI calculator, I would say that E button is your times 10 to the button. That's what E means, times 10 to the. It's just a quicker way to say it. So this 11 has no place in here. It's got no special word. Sorry, 11, you suck. We don't like you. So I've got to make it go to 9, because that's the next thing down that has an actual name.
So
Right?
you're saying, Jeff, that in scientific notation, to the 11th place, that does
Just
not
happens,
exist.
yeah.
It's not in math.
It just happens to have no English translation.
Okay.
So again, we really need to look at math as what it is. Math is a foreign language, right?
I love math, but I'm just
I love
right
it.
there.
But you're all basically taking math as a second language class. Do you guys understand what I'm saying? It is a foreign language. PEMDAS is the grammar, which is why it sucks the most. If you've ever learned a new language, what sucks the most is grammar. Vocabulary you can just memorize. Grammar sucks. Especially if you had to learn English. I'm really sorry if you had to learn English, because we really screwed the shit out of this language.
Yeah.
It's easy for us that we're born here.
Yeah.
But if you weren't, you're like, what the hell were you thinking? We were all high. We are all sorry. Okay. So I really want you guys to get to the place. I know I want to go to the 9th because it has a name. 11 doesn't, and 9 is the next one down. So I've got to move this sucker twice. Because if I do that, this becomes times 10 to the 9th now. It wanted to go 11 places. If I go twice, now it needs to only go 9 places. So this is not the same as making it into a decimal form. This is not that at all. This is just trying to make it match with what has a word. So now that'll be 257 billion. So this is a problem where You know, you're doing math, so that kind of sucks, but it's also talking about how much money America owes and how it's going up and up and up and up. So that sucks also. So it's like a double suck whammy. So I am sorry. Okay. Man, I can't make you guys smile. We're shit. All right. Well, let me clear that.
No, Jeff, you make it
Yes.
exciting. You know, we
Well, you're fine. I
appreciate that.
I'm not fishing for anything. I'm sorry, dude.
No, I'm not saying that you are, but I mean, thanks for trying to, thanks for making it somewhat exciting with your tonality. That's appreciated always.
Okay.
Yeah.
So why is this problem much nicer than what we just did? Why is he so much nicer?
That's the
Say again, sorry.
12 is trillion.
Yeah, it translates.
12 power got a name for it in the
12 power
language.
got a name. I don't have to do any of this weird shit, right? So this will be, let me see if you guys can do this though. So what would this be then? If you just write this, it doesn't make a lot of sense, but let me just start here, 3.233 trillion. You do hear that, but what's a better way to write that? Well, I mean, this is, I'm not going to get too much. How would I write that? Trillion, yeah.
10 to the.
It's already there. We already, we
Times
took
10
it.
to the, 12.
So it'd be 3,233
Billion.
billion,
Mhm.
right? Is that enough? Yeah, that's
zeros.
billion. Billion looks crazy. 3, 6, 9, 12. See how that matches up? So that's how the 0.233 falls in. It just goes right in the next places. So this is like the billions. But this is extra. I'm doing extra here. It's not really what this wants. So $3.233 trillion. That's what it was in 1990, kids. All right. Yeah, I know. Lakeisha's shaking her head. I agree. Just screwing over future generations. That's all. No big deal. All right. Let me clear that.
So writing that in scientific notation would be.
It's already in scientific
To
notation.
the.
Oh, so if I wanted to write this without an E, it would be 3,233 times.
Same thing. 10 to the 12. Yeah.
Yeah. So the times 10 to the is what E means.
Right.
I like it. All right. Let me clear this. Is that all right? Is anybody still copying that stuff, Dan?
Go ahead and make the sounds effect.
I'm sorry,
Thanks for
Nikki.
saying what the E means, because when I put it in my calculator yesterday, I was like, oh, it must mean error.
I don't blame you.
You didn't say the sound effects when you erased it, Jeff. Wow.
Oh yeah, sure. That's for me. Get something out of it too. That's great. But that's mostly just for me. Let me see. Sorry, I hate when this book bounces.
I'm a kind of a sound effect guy too, so I like to hear it.
I gotcha. Now, of course, the last 5 years, the suckers, Shema! There's a sound effect.
Hey,
All right.
Jeff, would you mind going back one more time to the problem solvings that we were doing? All right. So I guess right now with the lesson, what's confusing me would be that I know that if it's a positive power, we are going to the right, and if it's negative, we go to the left. Now, when it comes to when we're dealing with more zeros, like 10th to the 10th or 10 to the 12th.
Sure.
You move your decimal. So let's look at 3.233 E plus 12.
Sure.
It's right below the 908 billion. If everybody in class is paying attention. Now, thank you, Jeff. So it's 3.233 tenth plus 12. So we would be moving it's 9. We only move the decimal one time, or we're gonna move the decimal 3 times.
So again, real quick, it depends on the question. The question here was just, what's the pronunciation? So that's why we said, 10 to the 12th is trillion. So this is 3.233 trillion. Because that's what this means. if the question was rewrite this in decimal form, like I actually did, right? I did this earlier. It would mean move the decimal how many places?
We would move the decimal all the way past the 3, all the way to the right,
So
and then we'll
1,
start our
2,
zeros.
3, right? 1, 2, 3, and then how many more places?
Well, we will subtract the 3
Alright.
times. How many times we move? So it would be 9, like
Nine.
the
1, 2, 3,
Lionel
4, 5,
said.
6, 7, 8, 9. I'm pretty sure I did that just a minute ago, but
Yeah, I know you did, but I am a little slow, and I it's not that I'm slow, but I can get confused really easily.
no, I'm with you. I'm with you.
And
It's okay.
and when I get stuck on something that I don't understand, like I'll be paying attention, but I'll be still thinking about like, fuck, why
I'm
is
with
this that and that this? So
All right. So it's really, you got to be really careful about what the question at the moment is to know what to do. So you're correct. This by itself only means move the decimal 12 times, make it big. But there are other questions that could surround this thing that I don't do that. But that is what that means. So in this case, it's got another name in English, so that's where I would stop. I would just say this is 3.233 trillion and it'd be done. Okay.
thank you.
You're welcome. So let me clear all that. Last thing I want to do is just look at the homework real quick so you know what to expect. There's some chocolate. That's always weird when I go flying past that. We're going to do it again. Chocolate. There's a whole thing about chocolate in here, but oh well. It's a little hard to do internet chocolate. So here we go. So here's your homework. There's the very first thing is very direct. It says just write each of these in scientific notation. That's all it says. But then you're going to have to interpret what to do with those. So this many million tax returns filed, and each taxpayer paid this much on average. So then the second problem says, how much total money did the government take in? So if I know how many tax returns are filed, and I know on average how much each one paid, how do I figure out how much total money that was taken in? So if I multiply it, yeah. If I have 148.6 million boxes, and on average they have 9,118 apples in them. How many total apples do I have? Well, boxes times apples per box. So you're going to have to multiply those two when they're in scientific notation, right? So you look here, perform the calculation in scientific notation, which is what we were doing earlier. See how I have a method to my madness? Okay. Right? Again, we're not going to do these problems. These are your homework. I just want to talk about a couple of them so you know what to expect. This one's going to be interesting. Some of these are going to involve division. Some of these are going to involve multiplication. But you can see how they're basically, am I going to multiply here? Am I going to divide here? Let me see. The earth is so far from the sun. Yeah, and then this is interesting. All right, so again, I'm not saying that every problem is going to be simple, but they're mostly going to be, do I multiply or do I divide these things to get the answer? All right, and you're going to have to work with scientific notation.
There's some long numbers in there.
That's the whole point, right? That's what scientific notation eats up for breakfast. It eats big ass numbers for breakfast. Yeah, especially when we're talking about the debt again. Talking about the debt, we got some big ass numbers.
Or the one where it says the stack how many dollars it would take to, and how high would the oh man.
Yes. Wow. Those are cool problems. So some students love those kind of problems. Some students are like, I'm never going to stack dollar bills to the whatever. Are you kidding me? If I stack all my dollar bills, it doesn't get to the roof. So I'm one of those the freaking sun. All right. But
yeah,
I hopefully you appreciate that they're making you work with the numbers, but in kind of creative ways. Okay. Otherwise, I think that's where I can stop. I want you guys to try to get into 1-7 and be ready tomorrow with questions, because I need to see where the specific problem spots are. And I can't see that until more people have tried it out. Hopefully, you're not too far behind in homework. I think the pace we're going at should be allowing you to keep up with homework pretty well. Let me know if that's not true. But wherever you are in homework, can you just try some from 1-7 tonight? So that tomorrow, or today sometime, so that you got some questions tomorrow. Thank you. That will help me do my job. Coolness. People are already leaving. So now let's say it's officially done, today's class. If you have any questions, hang out. Otherwise, you're move.
Not
Yes.
questions, but need to speak with you in regards to you told me towards the end of class to get with you on homework. So what I'm going to do is I'm going to, when I get off of this, I guess I'll take a look at it.
Did you watch that video I did about how to access my feedback?
Oh yeah, I know how to do all that part. It's just like I said, I was only getting part of it, and that's because I was on the phone.
So try it on the laptop. If you still have issues, email me and I can download it and send it to you. But I'm almost certain the laptop's going to take care of your issue.
Okay. That's all I have, and see you tomorrow.
All right. How's the rest, everybody? You guys all right?
Yeah, I had a question.
Yes.
Because I resubmitted one of the assignments with correction. It says now it says late.
Oh, okay. So when you resubmitted it, do you mean you corrected it? Oh, yes. Corrections cannot be late. The system will say late because you turned something in after the due date. But if they are corrections, you are fine all day long. I can see the history of all the submissions.
Okay, cool.
So to me, in the history, it only starts to say late at the submission that was late. All the other ones are fine. Okay. So if your corrections are the ones that say late, I don't care. They're due the day of the final. Who cares? Okay, I just wish I had like two due dates I can give, but I can't. I have to give one due date. So the system's really dumb. It just goes, you're turning something in late.
Okay, cool. Thank you. Thank you, Jeff.
All right. Everybody else all right?
I have some question about my homework and
Yes.
1 point.
1.5. 1.5.
It's like number 3. I don't know. I think I'm mistaken with the I get confused when it's the written question. So I don't know what should I say exactly.
All right, let me look you up here. You're looking at number what?
It's 1.5, page 71. Yeah.
Yes.
On number 3.
3. Oh. Yeah. So just be a little more specific. Highest number, there's 2 numbers. So the highest second number.
So I said later, I'm trying to correct it. If I want to just ask you if I'm right or wrong. So I said later, we need to find when the temperature was the highest during what time during the day. Is that correct? Or
the highest second number, right? The highest. So when you say highest number, there's 2 numbers. There's the first piece and the second piece of the point, right?
Okay.
So in the table form, you could say the highest number in the second column or the highest number in the temperature column, or
Oh, so here in the graph, it's just saying in the graph.
No. So number 3 is all about the table, and then number 4 is about the graph.
Oh yeah. You're right.
Yeah.
So I see let's say when I'm seeing at 1 o'clock, it's the higher, and after that, for 3 hours was the higher.
Yes, sure. But it's easier to do on the graph, right? Because to find the highest point, I just find where the peak is. I don't even have to look at the axes until I find it, and then I can look down to see what time it is, right? So for number 4, you don't have to. I don't think I really necessarily said it was wrong. It's just right. If you look, you just find this point, and then you look down. So it's like the maximum point. I understand, but I don't know. I shouldn't even have circled this because I know what you mean. But just the peak, just the highest place.
The highest peak, like you mean.
Yeah, you're good. You're good. I think I was just being overly, what do you call it?
There's for this one, when we made it not from the 0 for the number 7.
Yes.
It
So
it shows
you're
like
just,
it's yeah. I'm sorry.
of course
Say
it doesn't start at 0. That's not the question. It's if you don't start at 0, what does that do to the graph? Is it like it makes what's it do? How does it compare to the graph how it looked before?
it looks like this one is like they're like higher.
Yeah, it's like stretched out, right?
Yeah.
That's all they're asking. What does it do to the appearance of the graph? It makes it look more stretched out. It makes the differences look more. Does that make sense?
Yeah. Like it looks like taller, like more higher.
Yes.
I mean, sorry.
Yes, higher and lower.
That
I mean,
looks
it makes
higher.
everything look more pronounced. So it makes it look like bigger change than it really was.
Mm. Mhm.
Yeah.
Like okay. I think
And
that's some more. I'm not sure.
yeah,
Yeah.
now look at number 8 real quick. The second graph. You tried to
Yeah.
draw a straight.
Yeah. Yeah. This one. Yeah. Too.
There should be a curve to it. You can see how the points want to curve, right? Because they don't line up on your line.
Yeah.
And
Like you
so
need me to just go to the points, not
yes,
did the
because an
straight
exponential,
line.
the idea of an exponential graph is it will curve, which is why we
Oh
don't
yeah.
call it linear because it's not a straight line. So your
Yeah.
points look beautiful. You just didn't connect them right. You should put a curve through them because that's what an exponential should look like. It should look curved, not straight.
But it's like going like straight with where I have put the points.
Well,
To me.
no. Let me see. Hold on. Let me share.
Maybe I didn't do them right.
No, you're. It's beautiful. It's supposed to curve. Do you see how it's above the points until the
Yeah.
end? So
Yeah.
really, it should look like this. It should be curved.
Just
I'm going to make it bigger than it's supposed to be, but it's supposed to curve through the points. It doesn't go
oh,
straight.
okay.
Yeah, I can't do it with this horrible thing, but oh well. So, and then this, I just put a question mark because you're supposed to explain graphically what's different. So I know a linear graph grows by the same value, but it looks like a straight line. And exponential will look like a curve.
Okay.
Yeah, that's the main difference visually.
It should be look like a curve, not a straight line.
Yes.
Okay.
Cool.
I got you. Thank you.
I like it.
Thank you very
So
much.
nothing major, no huge mistakes, right?
I get problem with reading. I have to read it a lot and a lot to figure out what exactly I should do. So it confuses me, even though when I was doing the quiz, I don't know, I get confused. Like I don't look exactly for the numbers and do them like correctly how they are. Like I was so upset of myself when I did the M&Ms one. I said, why? I know what's the number for the M&Ms. Why I did it with 100? I'm not doing anything with that. So I really like get upset about myself.
That's
But at
another
least
reason
I know
why
it.
that's another reason why I like to have people make corrections, because then you feel like you can go back in time a little bit,
Yeah,
right?
it's better, of course, of course.
Yeah.
And you gave me the chance like to make it like the grade better too. Thank you very much.
Yes. Cool.
Okay, thank you for your help. Bye.
You're welcome. See you.